Alright, let's see this very important and high frequency interview question. But before actually proceeding, I would like to urge you to subscribe to my channel if you haven't already. And also after watching this, do leave a like if this video really helped you, right? This will keep me motivated in creating more such quality content for cracking big tech product companies. Alright, so here's the problem statement for this question. So there's a geek who has forgotten the password to his super locker, right? However, he remembers two things: the number of digits in the password, which is given by n, and the total sum of its digits, which is given by s, right? He also recalls that his password was the largest possible number of n digits with a digit sum of s, right? Now our task is basically to help this geek reconstruct this number. So for example, if my input is given by n equal to 5 and s equal to 12, that is, it should have 5 digits in total and the sum of all the digits should be 12, right? So my expected output here should be 93,000. That is 93 and 000. Because this is the largest number possible with 5 digits whose sum is equal to 12, right? So that's what we need to do in this problem. Now maybe you can just pause this video here and try to think of a solution. And once you are done, you can just come back and check the solution. Okay, so let's dive into how to solve this. So here's how we approach this problem step by step, right? So first of all, we initialize an empty string, right, called res to basically build the result, right, that we have to return in the end, right? Now we set a variable sum equal to this s, right, which is given in the input. And this sum we will just keep reducing as and when we are adding new digits to res, right? Now we start from digit 9, which is basically the largest possible digit, right? And we go down to 1, right? And for each digit in this process given by I, we will check if I is less than or equal to the current sum, right? If it is, then we will just append I to the result and subtract it from the sum, right? And we will just continue doing this until the length of the result that is given by the res string that we are building becomes equal to n digits, right? Either that or the sum reaches 0, right? So let's discuss both of these cases one by one. So if the sum reaches 0, right, then it would mean that we have got the required digits, right, which sum up to the given input sum, right? And now we can break and pad the required number of zeros at the end to make the total length of the res string equal to n, right? That's what we will do if the sum reaches 0 and we have got the right digits, right? And in the other case, if before even the sum reaches 0, if the total length of res becomes equal to n, right, it would mean that we cannot add more digits to res anymore and hence we cannot get the given sum, right? And so we would return -1 in that case, right? So if at any point the result exceeds n digits or if the sum cannot be fulfilled in the end, we will just return -1 as it is not possible, right? Now let's see a step-by-step walkthrough using this logic, right? So we start with sum equal to 12, right? And an empty res string, right? Which we will keep building, right? Now we will try to place the highest digit possible, which is 9, right? So now we are trying I equal to 9, right? Now if you see, we will compare 9 with 12, right? And of course 9 is less than 12, right? And since it is the highest digit, I can just place it in my res. So my result so far given by the res variable will now become equal to 9, right? Because 9 will get appended to res, right? Now I will move to the next number, which is 8, right? And now since 8 is greater than 3, 3 being my current sum, which is left, so I cannot add 8 over here now, because if I add 8, the total sum will become 17, which will be greater than 12, right? So now I need a digit which is actually lesser than or equal to 3, right? So I will just move to the next number, which is 7. Again, 7 will be greater than 3, so I will skip 7 as well. Now again 6 is greater than 3, so again I will skip 6. Then I will move to 5. Again I will skip it. Again I will skip 4. And finally when I reach 3, it becomes lesser than or equal to 3, right? which is my current sum. And so now I will add 3 to the result, right? And now at this point, if you see, my new sum became 0. And now since the sum is 0, we can only fill the rest of the digits with 0, right? We don't have any other option. So we add 3 zeros one by one at the end, like this, right? So in total, it will become 93,000 and it has 5 digits and the digit sum is 12, right? And this way our mission got accomplished. So this is the entire solution. And by the way, this is a greedy approach to solve this problem where we are trying to maximize the number by considering the optimal digits, right? And if you are new to greedy algorithms, I will share a video in the description of this particular video where I have explained the greedy algorithm in general and in detail and have also solved a very good example using it. So do watch that. Now talking about the space and the time complexity here will be order of n, which will be linear, right? As we are just going to do maximum n iterations in the worst case to form this number of n digits, right? And since we are not using any extra space over here, the space complexity will be constant. It will be order of 1, right? So that's the entire solution. Now let's code this. So let's write a function largest number where n is the number of digits and s is the sum, right? So we start by initializing a variable sum to s, right? And we also declare another variable res and we initialize it to an empty string to build our result, right? And we also declare another variable I to start checking each digit from 9 down to 1, right? So we start a while loop that goes from digit 9 down to 1, right? And if our current digit I is less than or equal to the remaining sum, which is held by the variable sum, we use it, right? We add it to the result and also subtract it from the sum, right? Else we move to the next smaller digit, right? Now if the sum becomes 0 at any point in time, we just break out of the loop. And also if the result becomes longer than the required digits n, right? In that case, the output is not possible and we just return -1 in that case, right? Now, after coming out of the loop, if the sum is still not 0, that is if the sum is greater than 0, it is impossible basically to form the number and hence again we can just return -1, right? Otherwise, we just pad the result with trailing zeros if it is shorter than n digits, right? And finally, we just return this as the output of our function, right? So that's the entire solution. I hope you understood it well. And now I will see you in the next video. Thank you.